Hello. So today we're going to be going through the Algebra 1, Module 1 vocabulary. Our first vocabulary word is the word algebra. Now, algebra, in its definition, is talking about a branch of mathematics. Now, this particular type of mathematics uses letters to fill in for unknown values. It originally comes from a book that was written way back in 830 CE. And this book was written in Arabic, and its English translation is the Compendious Book on Calculation by Completion and Balancing. And you can see all the three words that I have highlighted there are the same word in each translation, English, Arabic, and Latin, and it means completion. If you notice, in Arabic, it's al-gabar, and in Latin, it's algebrae. I don't know how to pronounce those, but they look pretty close to algebra. And what it means is you're just completing something. Something's missing, and we're going to figure out what that is. And so with algebra, the things that are missing, we stick some letters in for as placeholders to hold the place until we can figure out what they are. Our next word is the word capacity. Now you'll see a few geometry words that we're going to go through here. They should all be reviewed for you, but we are going to come across them in our material. So we want to make sure that we go over them just in case somebody's not familiar with them. So capacity is the most that something can hold. Say we have football stadiums or basketball arenas, and the capacity is the total number of the max capacity is what the fire marshal has said, the maximum number of people that are allowed in that building, okay? When something's at capacity, that means it's filled as much as it could be. So that's what capacity is. Volume is the amount of space that is occupied by an object. So how much room something takes up, essentially. Circumference is the distance around a circle. Say we have a circle here. That's not really a well-drawn circle, but it's a circle. Basically, the circumference is exactly what I drew, the line that goes around the circle that encompasses it. Now, the traditional way of writing this is C, or circumference, equals 2 pi r. R stands for radius. Pi is an irrational number, which we're going to get to a little bit later. 2 is a number, and then C stands for the circumference. Now, if you're familiar with geography, the radius is that distance. Well, the diameter is twice that. So 2 times r is the same thing as d, or diameter. So you could also write it as circumference equals pi times diameter. Next one is perimeter. Now, perimeter means the sum of how long all the sides of a polygon are. Well, that word polygon, you might not know what that means. So a polygon is a shape that it doesn't turn in on itself. It's convex, not concave, and it's all its edges are made out of line segments. That means it's not a circle, okay? It's not a half circle. That's not a polygon. Has to be made out of straight line segments, right? So a polygon is the only thing that can have a perimeter. A circle has a circumference, all right? So to find the perimeter, whatever this side measures, you add that to this side, and this side, and this side. And remember, polygons can have multiple sides. They can range anywhere from 3 line segments all the way up to innumerable amounts, but once you get up into the millions and thousands of sides, it starts to look like a circle. But polygons can have any number of sides. The one we are most familiar with are the 4-sided shapes and the 3-sided shapes. Our next vocabulary term is Pythagorean theorem. Now that word theorem, that's another one we really might not know. A theorem is from geometry. It's a proven chain of reasoning. Okay, you prove that something's true or false. And so the Pythagorean theorem proves how to find the sides of any right triangle. Now, a right triangle means it's got like this special corner right here, okay? So this is a right triangle when we have this special type of corner right here that makes a 90-degree angle. And the Pythagorean theorem tells us that we can figure out what each of these sides measure, okay? These two that create the right angle are called the legs, and those can be labeled A and B. It doesn't matter which one's which, okay? You can have this one be B and this one A, or you can flip it and have this one be A and this one be B. However, the right angle is always pointing to what's called the hypotenuse, and that's always, always, always going to be C in our mathematical problem, okay? And this is the theorem that allows us, through the theorem, we can prove that this equation will always get us the right measurements of the sides of this right triangle, okay? So the next word we have is factor. There's two different things when it comes to math that factor can be. One is a noun. So factor as a noun means that it's the numbers that are going to be multiplied together to find a product. So if we had 2 times 6 equals 12. 2 and 6 are both factors, while 12 is a product, okay? So a factor is the numbers, either one of these, they're both factors. This is a factor, this is a factor, and 12 is the product, okay? So that's it as a noun. So when you're told to factor something, or you're given the instructions to find the factors or to factor something, that means we need to figure out what numbers we can use to multiply to make that. So if we have the number 6, what are some factors of 6? Well, 1 times 6, those are factors, and 2 times 3, those are factors, okay? So if we were to factor 6, the factors of 6 are 1, 2, 3, and 6. These are all the factors of 6, meaning they can be multiplied by something to make that number, okay? We factored as a verb the number 6 to find the factors as a noun of the number 6. All right, so that has to do with what's going to be multiplied. Now, integer. Integer is a fun one. Hopefully you're familiar with the circles that build on each other, the diagrams. Usually they're used for thinking or planning or brainstorming, right? And when they overlap, that means they have something in common. And when they're apart, that means that they don't have something in common. Well, we have different sets of numbers in math. You know, humans, we like to classify stuff and put it all in its groups. We like to have things organized and orderly and have them named and set apart. So we've done that with numbers. So we've taken sets. And the first set of numbers is what we call natural numbers, okay? And that's the numbers that you count with, like 1, 2, 3, 4, 5, etc., going up. Those are natural numbers, okay? And then you go a little bit bigger, and you have something called whole numbers. I don't know why my brain gave out for a minute there. Whole numbers, and whole numbers are actually 0 and then also the natural numbers. So the only difference between whole numbers and natural numbers is the number 0, okay? So 1, 2, 3, etc. 0, 1, 2, etc. Okay? Then when you get to integers, you start introducing negative numbers as well, okay? So when you have integers, it can go on. The dots mean it goes on forever to infinity in that direction. So this is going to go on forever in both directions. We have 0, 1, and 2, and it's going to continue on, and 0 -1, and -2. And it continues on in that direction too. So integers are basically whole numbers as well as all the opposites of the whole numbers, okay? So any number that is not a fraction or a decimal. So integer, it can be positive or negative. Rational numbers. Okay, now rational numbers, the traditional definition for it is any number that can be expressed as a fraction of integers. That means that if you can put it like 2/3, okay, that's going to be a rational number. A whole number can also be a rational number because let's take the number 4. You can write that as a fraction because you can have an implied number 1 as the denominator, right? So that technically can be written as a fraction. Now, I personally prefer the definition when it's used with the decimals. Any numbers whose decimal terminates, which means ends, or repeats. So what that means is you're going to have a decimal that terminates. The decimal for 4 is simply 4. Our implied decimal there is a 0.0. So it's terminated, it's ending. It doesn't continue on, right? Well, if you have a fraction 1/2, what's that decimal? Well, that's 0.5. Does it continue? No. So that terminates. It ends. So that's a rational number as well. Let's think of a fraction like 1/3. Okay. 1/3 has a fraction or a decimal of 0.333, and so on. It keeps repeating and repeating, and we indicate that with a line over it, right? When you write a fraction that repeats, you don't use the dots. You use a line over the top of it, okay? So this is a decimal that's repeating. This is a decimal. These are decimals that terminate. When you use, I prefer the decimal explanation because most of us in algebra are going to be using calculators. Calculators usually give their answers in decimals instead of fractions. If you have a fancy graphing calculator, you can set it to show you some fractions, but its default setting is to have decimals as the answer. So I like to give you the definition of rational as a decimal. So if we had rational numbers, which, you know, makes sense, that's what rational means, then we should have some numbers that don't make sense. In other words, irrational numbers. So irrational numbers, I want to give you some examples before I give you the definition. Some examples are Euclid's number, the number e. Huh, that's weird. Okay, what about the number pi? We might be more familiar with that one. Those are both examples of irrational numbers, okay? And what it means is it's a number that has a decimal that never terminates, never ends, and never repeats. If you take the number pi and you figure it out, you're going to use a pretty fancy formula. It's basically just the circumference of a circle divided by its diameter. But in order to figure that out, you gotta know some stuff. And once you start working on it, you can continue that problem to determine this number and never end, and it never repeats. It never has a single series of numbers that begin to repeat. They just go on and on forever. And same with Euclid's number. Some other types of irrational numbers that never end and never repeat are going to be seen as numbers that have the root symbol on them. We'll figure out in a later vocabulary what that's called, but we generally know this as square root, okay? So the square root of 2, that's an irrational number. If you plug that into your calculator, it's going to give you a decimal that never ends and never repeats. That's how you know it's irrational and not rational, okay? Square root of 7, square root of 11. There's a lot of these. There's a whole bunch of irrational numbers. They're numbers that just don't make sense to us because there's no way to end them. The only way to write it accurately is as a symbol or with the square root symbol. If you were, we know pi as 3.14, but that's not really pi. If that was pi, it would have ended, right? So it keeps going 3.1415, etc. Well, we chose a spot, just a spot. We felt like cutting it off at and said, okay, we're going to round to that decimal place, and that's going to be an estimate. So pi is approximately 3.14. It is not equal to 3.14. It is approximately, or an estimate of 3.14. Okay, so irrational numbers. Numbers with a decimal that never terminates or repeats. Radical. Well, this is what we were just talking about, that square root symbol right there. It has a name, a special name, and it's called a radical. Now, most of the time, we know this as a square root, but it can also be a cubed root or a higher powered root, okay? So this symbol just means root. Now, when there's no number in it, it's an implied 2. So that means math has a lot of things that just disappear. They're like magic. We know that they're there, but we can't see them. And that's how it is with radicals and square roots. When you have a radical without a number, it's an implied number 2, meaning square root. Okay, so this symbol is called a radical. And that brings us to the next term, which is radicand. So that is simply the number that's under or in the radical there. Okay, so in this case, we have the square root of 2. 2 is the radicand. All right, moving on. An expression. So in math, it's a foreign language. I mean, some of y'all kind of already feel like that, right? Sometimes you're just looking at it and you're like, it just doesn't make any sense. It's like a foreign language. Well, that's because it is. And once you start to realize that and think of it like that, it becomes easier. Math as a foreign language lets us know that we need to be able to translate between English and math. Now, in order to do that, you have to have sentences, right? We have grammar and sentences and sentence composition in English. Well, it's going to be the same way in math too. So an expression is an incomplete math sentence, meaning that there's no equal sign. So a general expression could be something like 2 plus 3. That's an expression, an incomplete math sentence. Or you could have a more complex expression or an algebraic expression. Remember, algebra uses letters and numbers. The letters are used to represent missing values. So we could have something like 2x plus 3. That's an expression as well, but that one is an algebraic expression. All right. Equation. Now, an equation is a complete sentence. It's not a fragment. It has all the information we need. And an equation would be something like, if we went back to 2 plus 3, it's now going to equal 5. This is an equation. An easy way to remember it is an equation has an equal sign, right? And an expression doesn't. Now, an equation has 2 expressions on either side. You could say like 2 plus 3 equals 4 plus 1, or even like this, 5 is an expression all in itself. It's an incomplete math problem. So either one of those would be equations. Our next vocabulary word is the word term. When we have equations or expressions, we have terms. Let's look at the expression we've been using so far, 2x plus 3. There are 2 terms in this expression, okay? Terms are divided up by any addition or subtraction signs you see, okay? So think of these as like little dividing walls. That's helpful when you come to division and fractions later on to remember that there's a dividing wall made of addition signs and subtraction signs, right? So this is two terms. This is one term, and this is a second term. A term is any combination of letters and numbers, and it's kind of divided by a plus or a minus sign. So our definition up here says either a single number or a variable. It could also say plus x. That would be just a variable. Or a number and a variable multiplied together, and then the terms are separated by plus or minus signs. Okay. So variable, well, we kind of used that just a second ago. So maybe you already know, but it's the letter that's used in place of a missing number. So 2x plus 3, this has two terms, and x is our variable. Any letter will do. It doesn't have to be x. Sometimes it's y, sometimes it's z, sometimes it's a, b, or c. Sometimes it's usually some variables are avoided, like r, which usually means radius, or d, which means diameter, or e for Euclid's number. The most common variable you're going to see is x, and then y, and then there's a variation of other ones as well. N is a common one. All right. So the next terminology is a constant. So sticking with our theme here, 2x plus 3. The constant is the term that does not have a variable. So that means it's this number, right? Now, a variable can vary. That's why it's called a variable. That variable in my expression there could be the number 1. It could be the number 2. Who knows? Could be 127. No matter what it is, that means that this whole term is going to vary based on the variable, because this term is going to be whatever this number is times 2, okay? But this term, it's unique, it's stationary, it's constant, it never changes, it's always the same. Why? Because it doesn't have a variable. It's constant because it doesn't vary, because it has no variable, all right? So hopefully you can understand what a constant is. Coefficient. Coefficient is going to be the number that's before the variable. When you have a variable being multiplied by a number, the number is always going to be placed first. That's standard form. Kind of like in English, when you have adjectives and you're describing something. You would never say the red big house. You just kind of know that something about that doesn't sound right. You say the big red house, right? We just automatically know the correct ordering of adjectives and adverbs. You were most likely never taught the proper order. You can go look it up right now. There is an actual list of orders of how adjectives and adverbs are supposed to line up prior to the word that they're describing. Well, it's the same here with math. There's a proper order that has to take place. The coefficient has to go before the variable, not after it, okay? So this is something that we're just gonna naturally do. And you know, because we're humans, we gotta name it. So it's called a coefficient. Now, remember, because they're touching and there's no symbol between them, that means they're multiplying. Okay, so this 2 is being multiplied by the x, 2 times x. A monomial expression. Remember, an expression was an algebraic, an incomplete math sentence. When I said, well, it's anything that can be used that's not, doesn't have the equal sign. So a monomial, mono means 1. Right? So a monomial expression is an expression with one term. That can be a term that is 2x, so it has both a coefficient and a variable, or it could even just be a single number, like the number 3. That can actually be considered a monomial expression. Most people wouldn't call it that, but it's a possibility. It's a correct classification. A binomial expression. Okay, well, if monomial, mono meaning one, was an expression with just one term, a binomial expression, bi meaning two, is going to be basically what we've been looking at, an expression with two terms. We have two terms here. So this is a binomial expression. I bet you can't guess what's coming up next. A trinomial expression. I forgot to write the word expression up there. But a trinomial expression is simply a polynomial. I don't think we talked about what a polynomial was. A polynomial is I think actually the vocabulary comes up next for polynomial. So I'll hold off on that. A trinomial is a polynomial or an expression, an algebraic expression that has three terms. So 2x plus 3 plus y. That would work. It's not what we would consider standard, but it works. You could also have something like x squared plus 2x plus 3. This one just feels better to us, doesn't it? It just feels more natural. We're going to get into what special type of trinomial that is in a little bit. All right, here you go. The word polynomial. I knew it was coming up. It's an algebraic expression with two or more terms. So poly means many. Okay, poly means multiple or many. A polynomial with two or more terms. Especially the sum of several terms that contain different powers of the same variable. All right, so that was a lot of words. Let's look at some examples. In other words, the mathematical translations, because this is written in English right here. Okay, so the same variable. So that means that they're all going to have the same letters. So the expression I gave us before, 2x plus 3 plus y, we have two different variables, the variable x and y. So this says especially the sum of terms that contain different powers of the same variable. That doesn't mean this is not a polynomial. It just means it's not a common one. It's not a usual one, right? One that's more commonly known as a polynomial are like the ones that we said before, x squared plus 2x plus 3. These have the same variable, x, and they have different powers. If you remember, powers means the exponential power. This 2 that's kind of floating up in the air right here. This x has a power as well, but it's one of those magic things in math where it just disappears. It has an implied power of 1. So this is x to the second power, or more commonly known as x squared. This is x to the power of 1, or x to the first power, okay? And there's no variable with this one. So this is going to be the format that you're going to see the most with polynomials. Now, polynomials, here you have one that is 4xy squared plus 3x minus 5. This polynomial has 3 terms, and it's an example of a polynomial. There are some things that polynomials can't have. So we're going to go over some things that they can have and some things that they can't have. Polynomial can have a constant. Remember, a constant is the number that does not have a variable. A polynomial can also have variables. So it can be either the same variable or different variables, but it can have variables, right? We have some variables here of x and y. It can also have coefficients. Remember, coefficients are the numbers before a variable. And it also can have exponents, all right? So these are all things that a polynomial can have. So let's find out, what can a polynomial not have? Well, a polynomial cannot have a negative exponent. We could not have the exponent -1 over here on this x. Now, you may or may not know what a negative exponent does, but that's okay. That's not important right now. What matters is it's not allowed, right? Well, it's allowed, but not as a polynomial. It can't be classified as a polynomial if we have a -1 here. All right, so the next thing is a fractional exponent. You can't have x to the 1/2 power either. That's not allowed either. Well, again, it can't be called a polynomial. Or you can't have anything with a denominator that has a variable. So you can't have, sometimes you'll have fractional terms, and if there is a variable and the bottom part of it, a denominator, it is not able to be a polynomial. Okay, so the main thing you have to remember with polynomials for vocabulary purposes is that it's going to be an algebraic expression. Algebraic means letters and numbers. Expression meaning it's not really going to have an equal sign, right? And it's going to have 2 or more terms. This is the main thing for you to remember about polynomials. If you are writing in your notes definitions, this is what you would write down, okay? Now, here, I've got some examples for you. Is it a polynomial? Is it not a polynomial? This one has 4 terms. It has constants. There's one constant right there. It has variables. It has coefficients and exponents, but it doesn't have any of these things. So this one is a polynomial. Over here, these are not polynomials. All right. So that brings us to standard form. I said sometimes when we looked at different expressions, they just felt more right than others. And that's because they were in standard form. That's what we're used to seeing. Standard form is going to be ax squared plus bx plus c, okay? And usually that's set to equal 0. And it's written such that the variable the exponents of the variables are going to go in descending order. So 2, 1, and 0. 0 because there's no variable here, okay? But if you have a polynomial with even more terms, like 27y to the 5th power plus 32y to the 3rd power minus 4y squared, this is also in standard form because all of our variables, their exponents are going down as we read this math sentence from left to right. So 5, 3, 2. It does not matter if they go in order. You can go from 5 to 3 and miss 4 when it's in standard form. It doesn't change. It's still in standard form, okay? As long as it's going down in order. And that is the end of our vocabulary that we had in Module 1.